Hello, we're going to be reviewing DriveView 9, which is Ellis Electric's VFD programming software. So first thing we're going to talk about is what DriveView 9 is, and as mentioned, DriveView 9 is a free software. You could download it right off of our website, elliselectricamerica.com, and you could use that for changing parameters, reading parameters, backing up parameters, making multiple backups of the settings, and monitoring. This DriveView 9 software will connect to all LS series VFDs, M100, G100, S100, H100, and IS7. Check out our YouTube videos. We do have different connection videos on our YouTube and other helpful tips. The main thing we're going to be focusing on for the first part of this presentation is the different connection methods and trying to clarify that up. Also, you could use our knowledge base, which is available at the top of our Ellis Electric America website. There's a little button that says knowledge base, and it's a searchable self-help database which shows cable part numbers for DriveView 9 and other different tricks for connecting and any kind of troubleshooting or technical support needs you could find on there as well. So as mentioned, the biggest question we get and confusion about DriveView 9 is just the multitude of cables. So here we're just listing all the different possibilities you could use to connect to the different series of VFDs. We have a Modbus 45 cable, USB, a Modbus Dongle, which is like a third-party device you could purchase, a DB9 cable with an adapter, which goes to another serial cable, Ethernet connection with an Ethernet IP card, RS-232 cable over USB, or even a USB mini cable. And we're going to be talking about all these cables, but what I want to do is I want to focus on just the two cables you need. So instead of having these 6 different cables, you could actually just have 2 cables and connect to any one of our VFDs. So the first cable is this cable, which is an RS-45 to USB cable, and this connects to the M100 and G100 VFDs. So it plugs right into the VFD's Modbus port. So on the G100 you pop off that little door, the M100 you slide off the keypad, locate that RJ45 connector, plug this cable, which we're giving you the item code right here for, plug that into that keypad port, RJ45 port, and then you could also plug the other side into your computer, which is just USB. And one of the tricks with this is that you are communicating over Modbus. Notice how it says 485. It also says 485 on the sticker. You want to make sure that your computer's device manager is set up for the same baud rate as the drive. And by default, the baud rate at CM03 is set for 9600 BPS. So you'd want to make sure that the device manager is set up for the same. So I'll show you guys that when we do a live demo a little bit later. That was the first cable. The second cable looks very similar. This is a USB to a RJ45 connection, but the S100, IS7, and H100 were connecting to the keypad port, and this is actually an RS-232 connection. So this cable will not work on the other drives, and the other cable will not work on these drives. But if you have these 2 cables, then you could connect any of our drives. So this is nice because it's a direct USB to 232. You don't need any adapters or anything like that. The baud rate is a bit different. It's 19.2 BPS. So you're going to want to make sure that your device manager shows that same BPS, otherwise you could have some issues. And here's the item code for ordering that cable. So outside of those 2 cables, depending on the drive series, we do have a few different methods you can connect. The H100 is our only drive that has a USB connection. So if you were to pop off the keypad and look under there, there's a USB mini connection. You could purchase this cable from us, or you could just find an old USB mini cable you may have sitting around the office or shop, and you could connect this up. It's not a proprietary cable. So this is one of the nice methods you could utilize just for the H100. Right here is the Modbus Dongle. So this is a third-party device. You could buy it off Amazon for about $6. The nice thing about this dongle is you could use this to connect to any one of the drives. So this is truly the only cable that exists which will allow you to connect to any of the drives. But it doesn't plug into the drive. You actually need to wire up 2 wires to S plus and S minus. So as some of you guys may know, S plus and S minus is our Modbus connection on the VFDs. All the VFDs have that S plus, S minus. So you're really just using the dongle as an interface to connect your computer to the Modbus network going to the drive. So your baud rate is going to have to match whatever the baud rate is on the drive at CM or COM03, depending on the drive that you're utilizing. And you could also connect to multiple VFDs. So if you have 10 VFDs on the same Modbus network all daisy chained, you could just connect to that same Modbus network and you could communicate, read parameters to any one of those drives. And I believe this is the last one we're going to talk about, with is a Ethernet connection. So a lot of guys will see that there's an Ethernet port on the front of the drive, or the keypad connects to an Ethernet port, and they'll try to connect an Ethernet cable from the drive directly to the PC. But you cannot do that. You can't do a direct Cat5 or Cat6 connection unless you have one of these Ethernet modules. Otherwise, you're going to need one of those serial or Modbus adapter cables we previously mentioned. But if you do have an Ethernet IP card, and most of our drives have the capability to install an Ethernet IP card on it, you could connect up. For example, we're showing you here at 10.90.112.69, and as long as your computer's on the same network, you could connect to it over Wi-Fi or just plug right into it with like an Ethernet cable, and you'll be able to connect to it, read the parameters, write parameters, monitor, do everything else that we're going to show you a little bit later. And then just like the Modbus RTU network, you could connect to multiple VFDs that are on the same network. If you do have for example, an S100, that card has a dip switch that switches between Modbus TCP and Ethernet IP. You would want to make sure that little dip switch is selected to Modbus TCP, otherwise you're not going to be able to communicate to the DriveView 9 software. So before we do our live demo, I just want to mention some of these tips, and you're going to see me go through these tips in our demo as well. First off, I highly recommend using the auto scanning feature, and as it's described, auto scanning just scans the ports and tells you what's okay, what's no good. So if it's okay, obviously you could go ahead and proceed with connection. If you see an NG, that means no good. A lot of times it's like something is set up wrong with the ports and the BPS that we mentioned, or maybe there's just a physical cable issue or something like that. But we'd recommend, verifying the baud rate as a starter. Next, we get a lot of calls about this message on the top right here, where it's saying the drive is a different version than your project, so you need to make a new project, and a lot of people get confused by it. So what I would recommend is when you select your code version, when you're selecting your model number and all of that at the project creation screen, just select a low number. So you can see we have 1.00 through 2.0. Just select like a 1.00 or a 1.10, and it'll usually let you connect, and you'll see the message on the bottom right here that says you're connecting to a lower version. So your project is not going to match your drive, but it's still going to let you connect. Proceed. You could just click yes, and then it's still going to let you proceed without having to make a new project, which you'd have to do if you selected a higher version. So I'll show you guys that as well once we start our demo right now. Alright, so here we have a couple of drives. We have a G100, and then we have an S100. And again, the connection is very similar on these, except that the S100 uses this USB to RS-232 adapter, and the G100, just like the M100, connects to this RS-485 cable. So very similar, but they're not going to be interchangeable. So all we're going to do is just plug right into this keypad port right here, and then plug the other side into our computer. Okay, so we're all connected up. USB on the computer end, going to that RJ45 Modbus connection on the G100. So I have DriveView 9 opened up here, and this is a project-based software. So you're going to want to start by doing a new project. I'm going to call this G100 demo. You may need to hit a drop down to select the right series of drive. We're doing a G100, and I'm going to pick a low version number just to try to eliminate any errors when I connect, as I mentioned earlier. Hit OK, and now we're ready to go. We're in an offline mode, so I could actually make an offline project. I could go ahead and click through all of my parameters and select what I want to do, and then I could dump it in, when I'm in front of the drive. But in this case, I'm connected to the drive, so I'm going to hit Settings. We're doing a Modbus RTU connection, and then if you hit this little setting box here, then that's where you could find your auto scanning port. So go ahead and click that and say yes to proceed, and if we scan everything, it'll say OK. Sometimes you may see no good. that would be when you would want to go to your device manager and double check your baud rate and your BPS. So how you would do that is you'd open your Windows, and I just start typing in device manager, and we're on COM8. So if I go down to ports, here's COM8. This is going to be correct. This is going to be at 9600. Sometimes you may see this is not at the right BPS. That'll cause issues. That's just a little troubleshooting thing right there. So this is okay. So now we should be able to hit OK and connect. And now everything went green on the bottom. We are online. So we're online. We're connected to the drive. The first thing you'll probably want to do is read the parameters. So if we click parameter read, I like to select this top box, and that selects all the parameter groups beneath it. If you're just playing around with a couple of the groups, you could maybe unselect a few. But I'm going to read everything in this drive since it's our first time connecting. You hit OK, and you're going to see this progress bar go across the screen, and it's going to do every group, DRV, BAS, ADV, and so on. And this will take maybe a minute. Alright, so once everything is done, you're going to get a message like this: reading is completed. Now all of the parameters are listed for each group. BAS, DRV, ADV. This is a default drive, so nothing has changed. Everything is a default. If you start changing parameters, you're going to see them change to a blue color. So for example, let's go ahead and if we go to our SPS group, so on the G100, there's the up-down operation group, which is just hitting up and down on the keypad. That's where you're going to see your ACC, your DEC, your XL, your DCell, command source, frequency reference source, and stuff like that. So that gets tossed into this SPS group. So if I double click this Excel time, and let's just change it to 3 seconds and hit right. Now that changed to 3 seconds. I could do the same for my DCell time, and I could write that. Okay. So we change that from default, and then if we were to pop out a report for this, if I hit this report button, you're going to see the changes from defaults are going to be listed as blue. So we could go down here and we could see our XL and our DCell time. So I just changed a couple of parameters. Some of these are going to be listed in blue because it depends on the capacity of the drive, versus the kind of the master data set we're comparing these parameters to. And then you could also go ahead and you could print this, you could save it as a PDF, you could export it as an XLS spreadsheet if you click this button right here. So there's a lot of things you could do there. Some people like to print it out and toss it in the cabinet or whatever. But all your parameter groups are here. So let's say I want to set up a PID loop. Kind of tedious to do on the keypad. Alternatively, you could just go to your APP group. You could go process PID. You could set your feedback source to, let's do I2 for 4 to 20. You could set your P gain to 200, your I time to 2 seconds, 50% set point, and that's all we need to do for a basic PID loop, set up those few parameters. And now you'll notice that these parameters are listed in blue, and that's because I put them in my project, but I have not written them to the drive yet. Okay, so if I want to write these parameters, you're going to do a parameter write. And you could write all groups, but I only changed these parameters, right? These 4 parameters. So this is in the APP group. So I'm just going to click APP, and then this way it'll only take 5 seconds instead of waiting a minute to write all the parameters. Okay, so now we set up a simple PID loop. Now it's not in blue anymore. Okay, but it will still pop up in blue on your report. So I hit that report button on the top, and if I go down to my APP group, here's the parameters I just set up. Now another thing you're going to want to do is, let's say you use this to start up a drive, is we're writing all this stuff over Modbus communications. And Modbus communications, you're kind of writing to volatile memory. So if you ever disconnect and then cycle power, you could lose your parameters. So before you disconnect, when leaving a job site, always hit this EEPROM save button, and this saves the memory to EEPROM on the drive. And so that way you could cycle power and you're not going to lose all those settings you did. So that's a very important step to do as well. So a couple more things I want to show you First is going to be the trips and the logs. So right here would show my trip log. Right, I'm connected to the drive and I don't have any trips, but if I were to trip out this drive in any way, I would start seeing this be populated, and you could also save the trip log in a file. So here's another trip log file I saved for a different application. We could see we had a drive called blower, another drive called new drive, and we were getting safety errors and stuff like that on this driver and output phase loss. So you could record trips in the DriveView 9 software. You could also click this drive detail button on the left here. You could see the software version number of the drive you're connected to, the capacity, the voltage and stuff, the communication state. Are we running? Are we stopped? What's our XL? What's our decel? Then we have 4 different gauges here that we could select for output frequency. We could do like, let's see, output voltage, DC link voltage. And as you see here, there's quite a few different possibilities that you could select. So we could even do like a PID reference and maybe a PID feedback. PID feedback, okay? Since we have our drive set up for a PID loop. And these gauges will update live in real time. So you may notice on the top here, there's this forward button, okay? And then there's this reverse button. So you have to enable this by going to that SPS mode. And I believe what we have to do is we have to set our command source to keypad. Let's give that a try. I'm going to go ahead and write that parameter in the SPS group. Okay. Alright, looks like the keypad's not working, so let me try putting this to 485. Let's do a parameter right. There we go. So now my drive just started up. You may hear the fan come onto the microphone here. So I could start and stop. I could reset fault trips here. I could run reverse. So let me just stop this. And just as a proof of concept here, if I go to my detailed information, let's first, we got to program a speed in here. Alright, so I went ahead and just programmed 50 Hertz onto my keypad. And now if I go to my display right here, I should be able, let's change this to output voltage and then give it a forward run command. You can see your speed increasing, you can see your voltage increase a bit. There's no load, so your voltage is going to be relatively low. Yes, that's just a basic speed adjustment. We could stop this. And I'm also going to go ahead and just turn off my fan on the drive. So I could do a temperature control. That might sound better on this video. I don't know if the microphone is picking it up. Alright, so the last thing I want to show you is the trending. So if I do trending, you could do a new trend. Okay, and it makes a little box like this. So I like to set the monitoring time as short as possible to make everything nice and smooth. You could scale the recording time in the x-axis. You could also scale the y-axis with these values per division here. So you could do 8 different channels. I'm just going to pick out, let's just do 3 channels. Then you could select what drive you're connecting to. So if you had more than one drive on your network, you could compare how they're both operating. And I'm going to go ahead and do output frequency, kind of similar to what we were looking at on those mechanical looking gauges. Let's see, output frequency, how about some output voltage, and maybe DC link voltage, which should be constant unless we have a power blip or any change in power. So if I scroll up to the top here, you could start your monitoring, okay? And then I'm going to hit the forward button. There we go. And you could see your drive ramp up right here. Stop it. So I have a very short XL and decel, so that's why it looks kind of jumpy. Obviously your motor would not be doing that in real life. That's just the limitation of this trending software. And then you could also record this too. So if you go back to your graph thing here, you could start a recording. You could do triggering. You could save that recording file. You could also copy the image onto a clipboard. They call this the scope screen. So you could export it into a Word document or PDF or whatever you'd like to do as well. So yeah, overall that's pretty much a crash course on the DriveView 9 software.